Here are the notes for standard 3.6, which is to identify third law pairs of forces and use them to solve problems. Newton's third law states that for every action, there is an equal and opposite reaction. And so basically when two objects interact with one another, the strengths of the forces on each object by the other are equal. Meaning that like when these two blocks are stacked on top of one another, that the block A is pushing down on block B, and block B is pushing up on block A, and both of those forces are equal to one another. So when we make force diagrams, we can identify third law pairs as long as we have two different objects and two different force diagrams. So here's a force diagram for the top object, object A. This object isn't moving. It has a constant velocity of 0, and so therefore the forces on it are balanced. And here for block B, we have the same thing, that there's gravity pulling it down and a normal force pushing it up from the table. But this normal force is bigger than the gravitational force because block A is also pushing down on block B. And so in order to find the third law pair, we need to find two forces that are the same type as each other. They involve the same two objects and they act in opposite directions. And so the gravitational force is between object A and the Earth, and none of these has both object A and the Earth in them. But this top force is a normal force that is an interaction between object A and object B. And this normal force down here is a force that's between object B and object A. And so they're the same type of force. They're both normal forces. They're also between the same two objects, objects A and object B, and this force is up and this force is down. And so because we have identified those as a third law pair, then what we can say is that the force of this normal force downwards must be equal to that normal force upwards because they are a third law pair. This is helpful when we're looking at multiple body problems. So this one has a person pulling two boxes along a frictionless floor, and they're making both boxes accelerate at 1.5 meters per second squared. So here's a force diagram for the smaller box back here. It has balanced vertical forces and then an unbalanced horizontal force, which is going to cause it to accelerate. Then the larger box has the same thing vertically, is balanced. It has a tension force pulling to the left from this box, and it has a tension force to the right from this person. And so if we consider just object B, we can calculate the gravitational force pulling down on the box, and we can say that because it's not accelerating in the vertical direction, that the normal force must be equal to that gravitational force. Then, since we know the acceleration from the problem, we can calculate the net force acting on box B, and then we can say that because the only unbalanced force in the horizontal direction is the tension force, that the tension force must be equal to the net force, so it's 75 newtons. And so we have the magnitude of all three forces on the first force diagram, but here's why the third law is important in solving these numerical problems, is that because we know that this force is 75 newtons, we can then say with certainty that this tension force is also 75 newtons because they're both tension forces. They include the same two objects, A and B and B and A, and they're pointed in opposite directions. So without doing this math right here, we would not be able to find this force on object A's force diagram. Then for object A, we can also talk about the gravitational force pulling it down, which is 980 newtons, and then similar to object B, we can say that the normal force must be equal to balance it out so it doesn't accelerate. And then the last force we need to find is this tension force. We know that the net force on block A needs to be 1.5 times its mass. So it needs to have 150 newtons more force to the right than to the left. And so we can't just apply that 150 newtons like we did on the first block because there is something that's counteracting that. But if we find the difference between those forces, we know that, if we find the sum of those forces, we know that a force that is 225 newtons would be 150 newtons larger than the 75 newton force. And so this last force has a strength of 225 newtons to the right. Thank you for watching.